Okay, in this video we're going to take a look at applying some of the formulas we have, our exponential functions, which are the real-life word problems. And this is from our last assignment, the last 3 problems. So in our example 14, we have someone finding a supply of 300 grams of U718. It has a half-life, so half-life H is equal to 3 years, and it was put into storage 22 years ago. So T is equal to 22 years. What was the original amount? So in this case, I don't know what P is. My equation looks like Y is equal to P times 1/2 of X divided by H, or T, sorry, in this case. It doesn't really matter if it's a T or an X right there. It's the time that has elapsed. So putting our values in here, Y is equal to the amount we have when we discover it, so that's 300. Our original amount is what we don't know, so I'm going to search for that. 1/2. T was 22 years, that's how long it was in storage, and my half-life is 3. Okay, so let's see what we need to do to solve this. I need to get P by itself, and P is multiplied by this term here. So I'm going to divide both sides by this amount. So I'm going to divide by 1/2 raised to the 22 over 3 power. And I will divide 300 by 1/2 to the 22 divided by 3 power. So P is equal to, when I plug this in my calculator, I'm going to get 48,387. I need to figure out my units. Since this is the original amount, I need to look at what units my amount is in. And it said grams, so this should be in grams. So when I solved this problem, I ended up dividing both sides by 1/2 raised to that term. Okay, problem 15 says that we want to have $2 million when we retire. That would be nice. We've got an account that will pay, we want $2 million. The interest rate we found was 9.6%. And unfortunately, that's very unrealistic these days. And we're going to leave the money in the account for 49 years. Last, we need to see how often they compounded. The problem doesn't say how often it's compounded, so we assume it's once a year, or annual. So the equation I'm going to use will be my growth equation, which is A is equal to P 1 plus R to the T. And the reason I'm not using my compound interest is that when it's compounded annually, it's once a year. So I don't really need to put those ones in. It won't hurt you, but you don't need to. So this is a simple growth problem. So I want $2 million. I don't know how much I have to put in now. That's what I'm trying to find. 1 plus R needs to be as a decimal. So I'm going to take my interest rate, 9.6%, and divide it by 100, which gives me 0.096. So 0.096, and it's for 49 years. So I'm going to go ahead and calculate what this amount is, and then divide both sides by it. So we'll be dividing by 1 plus 0.096 to the 49th. These will cancel. And on the right side, I divide by the same amount, 1 plus 0.096 to the 49th. I'm going to plug all of this into the calculator, so 2 million. That's 6 zeros, divided by, parentheses here, 1 plus 3.096 raised to the 49th power. And make sure you do the raised to, not just multiplied by. And then enter. Then I'm going to come up with $22,403.34. When we're dealing with money, we always want to go out to cents. So this tells me that he needs to, or whoever it is, needs to deposit $22,403.34 right now if you want to have $2 million in 49 years. That seems very doable, doesn't it? Or very much worth it anyways. Okay, last problem we want to take a look at is another money one. And this one we're trying to find the time. So we have bought a house for $315. $315,500, sorry. It's a bit difficult to read that 5 there. It appreciates at 8.7%, which is actually a little bit lower than it is in Round Rock right now. Our houses are appreciating at a much faster rate. We want to know when will it be worth $1 million. So we're trying to find T in this example. So we're going to use that same growth equation. A is equal to P, 1 plus R to the T. Let's fill in everything we know. We know A, we want to know when it's worth $1 million, is equal to P, our original amount, so $315, and $315,500, that's important. 1 plus our interest rate as a decimal, so 8.7 becomes 0.087 to the T. So the first thing I need to do is divide both sides by 315,500. Okay. We want to make sure that I do not make that same mistake with the 315,500. There we go. We get 3.1696, because I had to round that, is equal to 1 plus 0.087 is 0.087 to the T. Now we've got an exponential equation with our exponent in, or our variable in the exponent, excuse me. So I need to rewrite this as a log. Remember how to do this. Log base 1.087 of 3.1696 equals T. Using our change of base formula, we will find this value by saying log of 3.1696 divided by log of 1.087 is equal to T. We're going to plug this in the calculator. 3.1696, close parentheses, let's put that as a reminder, divided by log of 1.087, close parentheses. And we get T is equal to 13.8 years. So in almost 14 years, her house went from $315,500 to $1 million in terms of its value. Excellent appreciation.